Welcome to Mitsubishi Electric Nagoya Works. Here, we will show you the production of programmable controllers, which automatically control various machines and factories, making them indispensable for improving production line efficiency. The programmable controllers produced by Mitsubishi Electric are sold under the MELSEC brand. They're widely used in factories that continue to implement advanced automation in fields such as automobiles, LCDs and semiconductors, food and logistics. They have gained a market share of over 50% in Japan. In this factory we will show you today, as many as 300 to 400,000 programmable controllers are mass-produced each month. We provide a wide variety of models to flexibly respond to the automation needs from our customers. This factory is capable of producing around 150 models per day and can constantly handle the production of around 1,000 models. This is all possible thanks to having a production system that utilizes eFactory. In this programmable controller factory, various initiatives using eFactory are being implemented at each process. We will now introduce some of these initiatives as we outline the programmable controller production process. Programmable controllers that work to control various devices in a factory can be considered as a small computer. Each one is equipped with electronic circuit boards inside modules that enable functions such as power supply, the CPU, and input-output. The process of mounting electronic components on bare boards is called surface mounting, and this process is performed in an environment that is free from dust and electric static to prevent adverse effects on quality. This surface mounting process can be roughly divided into three processes: the solder printing, electronic component mounting, and soldering. Here, the PCBs for multiple programmable controllers are mounted together on a large board. Each process has thorough inspection under the strictest quality control standards. A laser marking machine is used to print two-dimensional barcodes onto each PCB so they can be individually identified. Firstly, a solder paste printing machine uses a metal mask to apply solder paste to only the specific parts of the PCB. The amount and status of the solder paste is then inspected by a solder printing image inspection system. Next, the electronic components are mounted onto the PCB that has been printed with solder paste. In this factory, nearly 1,000 electronic components are mounted on each PCB using multiple mounting machines. While recognizing the size and thickness of the components with the built-in cameras in those mounting machines, electronic components are mounted at a high speed of approximately 7 components per second with high accuracy. After components are mounted, PCBs are heated in a reflow oven for a predetermined time to perform soldering. All the PCBs used in different models of programmable controllers are manufactured through this process. After mounted with components, the PCBs are inspected by automatic appearance inspection machines, and any PCBs that failed are then manually inspected. The fully mounted PCBs are subjected to a final inspection consisting of automatic appearance inspection and the operator's visual inspection. We are committed to thorough quality control to ensure that our customers never receive defective products. After soldering is completed, PCBs are inspected using an automatic appearance inspection machine with a built-in camera. In the visual inspection process, operators scan the two-dimensional barcode on the PCB, display the area determined to be defective by machine, and inspect the actual PCB, comparing with data on the screen. The results of the additional manual inspection is entered into the GOT. This information is linked to information such as production conditions and the accumulated data that can be analyzed to reduce the rate of defects. PCBs that have passed the visual inspection are fed to the assembly floor by a vertical conveyor. High-density PCBs that are mounted with many components undergo an in-circuit test where properties such as continuity are checked. After that, individual PCBs for each programmable controller module are cut out of a large board. Finally, they are blown with compressed air and undergo a visual inspection to ensure there are no defects before proceeding to the assembly process. An advanced production system that supports and improves the capabilities of the people on the production floor is also applied to the assembly process. The assembly process must handle the production of 1,000 models of programmable controller modules in small batches. Therefore, we adopted a cell production system to allow flexible switching between production models. With this system, instead of dividing up the labor between multiple people, a single operator is in charge of an entire work procedure. Automation of high-mix production may result in an increase in equipment stop loss due to model changeover. Therefore, manual operations are indispensable for efficient production. However, cell production performed by a single operator can be complicated, and it takes time to learn all tasks, increasing the probability of a human error. In this assembly and testing cell, mounted PCBs are screwed in place and fully assembled. To ensure that operators learn their work procedures quickly and to prevent errors, the Smart Work Navigator system that utilizes the power of eFactory has been adopted. This system allows operators to accurately perform complicated tasks that vary from each model and enables high-mix, low-volume production that meets the needs of our customers. In addition to human assembly, automized assembly work using robots is also being promoted, and the optimum production method is selected for each model. For models with a high production volume, we are promoting automatic assembly with robots using eFactory. Programmable controllers generally consist of a combination of several modules, depending on the type of control and the device to be controlled. These various modules are mounted on a single base unit. As there are only a few base unit models that are suitable for mass production, their assembly is automated using 3 robots that perform everything from PCB mounting to screw tightening, connector insertion to performing a communications test, and finally packaging for shipping. These robots can perform picking of irregularly spaced parts thanks to their 3D vision sensor and smart robotic technology. They can also reliably insert connectors thanks to their inbuilt force sensor. In this assembly cell, robots and operators work together to achieve a space-efficient production system. The robot operational data, assembly quality data, and production performance data are linked to each product and recorded in a database in real time. This makes it much easier to manage traceability. Even if a defect is found in a robot or production equipment, we can trace and identify the affected products. After assembly and testing, the programmable controllers are then transported to the packaging area. After completing assembly, production rating labels are printed on each programmable controller and they are transported to the packaging area. A variety of data collected during the production process are linked to the serial number printed on the production rating label. This can then be used to check the production history of a particular unit. After being carefully packed into individual boxes, the programmable controllers are delivered to customers not only in Japan, but all over the world. They are then put to use in various applications. As you can see, this programmable controller factory implements continued improvement initiatives using eFactory that allows streamlined production to meet diverse needs and ensure that the highest quality products are delivered. Through the full utilization of data collected from automated equipment and human operation, we are committed to continuously enhancing productivity and quality as we follow the PDCA cycle for improvements. Thank you for watching today.